On December 10, 1945, Albert Einstein addressed the Fifth Nobel Anniversary Dinner at New York's Hotel Astor. World War II had ended only months earlier, and the atomic bomb had revealed a terrifying truth. Science had given humanity power faster than politics had gained the wisdom to control it. Einstein opened with a warning. The war is won, but the peace is not. Why would a scientist speak this way at a celebration of achievement? Because Einstein understood that discovery is never only about what becomes possible. It is also about what human beings choose to do with that possibility. His own life had already changed modern thought. Born in Germany in 1879, Einstein studied in Switzerland and struggled at first to obtain an academic position. At the Swiss Patent Office, he spent his spare time questioning assumptions most physicists accepted. Then came 1905, his miracle year. In a series of papers, Einstein explained Brownian motion, advanced the quantum theory of light, introduced special relativity, and revealed the relationship between mass and energy. His general theory of relativity transformed gravity from an invisible force into the curvature of space and time. He received the Nobel Prize in Physics for explaining the photoelectric effect, work that helped lay foundations for solar cells and electronic sensors. But one equation became his symbol: E equals mc². Energy equals mass multiplied by the speed of light squared. The equation does not mean that every object is constantly exploding. It means that mass is a concentrated form of energy. Because the speed of light squared is an enormous number, even a small loss of mass can correspond to a tremendous release of energy. That principle helps explain why nuclear reactions can produce so much power. Accuracy matters. Einstein did not discover nuclear fission, build the bomb, or work on the Manhattan Project. Fission emerged from experiments by Otto Hahn and Fritz Strassmann and was correctly interpreted by Lise Meitner and Otto Frisch. Einstein's equation explained the deeper relationship between the missing mass and the energy released. Einstein did play an indirect historical role. In 1939, fearing that Nazi Germany might develop an atomic weapon, he signed a letter urging President Franklin Roosevelt to support uranium research. After the war, he became a leading voice for international control of atomic energy and against nuclear conflict. This creates the speech's first educational lesson. Knowledge and wisdom are not the same. Knowledge tells us how to split an atom. Wisdom asks whether we should, under what conditions, and who must be protected from the consequences. The second lesson is that achievement creates responsibility. A person may not control every use of an invention, but expertise creates a duty to warn society when danger becomes visible. Einstein did not retreat into equations after Hiroshima and Nagasaki. He used his fame to argue that such power required international cooperation. The third lesson is intellectual independence. Einstein's greatest breakthroughs began with simple questions. What would light look like if you could travel beside it? Would time pass identically for observers moving at different speeds? Could gravity be understood as geometry? The questions sounded strange because they challenged ordinary intuition. That is often where important thinking begins. Yet Einstein's story also teaches humility. A brilliant mind can be right about one problem and wrong about another. He resisted parts of quantum mechanics and spent years pursuing a unified theory he never completed. Real intelligence is not the performance of certainty. It is the courage to test ideas, accept evidence, and continue learning. The fourth lesson is that science is a tool, not a moral compass. The same understanding of the atom can produce electricity, medical treatments, scientific discovery, or weapons capable of destroying cities. Technology magnifies human intention. It does not choose the intention for us. Einstein's speech therefore moved beyond physics. He argued that durable peace required justice, cooperation, and concern for other human beings, not merely more intelligence, stronger institutions, or better machines. His message can be reduced to 5 practical principles. Question assumptions. Follow evidence even when it disrupts familiar beliefs. Distinguish technical ability from moral permission. Accept responsibility for the consequences of expertise. And measure progress not only by power, but by whether power improves human life. Einstein changed our understanding of light, time, gravity, matter, and energy. But his deeper warning was about character. Humanity had learned how to unlock energy hidden inside matter. The unanswered question was whether it could unlock enough wisdom.